In this video we'll use natural language processing on Wikipedia articles to extract several interesting things, and we will save them into a NoSQL database, specifically a MongoDB one. I will show you how to use several Python libraries used in production in the industry. In particular, we will load the articles using Beautiful Soup, then extract the entities using spaCy, then extract keywords using Yake, then summarize each article using PySummarization, and finally extract certain elements from the tables in the HTML. Sounds fun, right? Instead of saving this into a SQL database, we'll use a NoSQL one. SQL databases are meant for storing columnar data, meaning that we insert one record as a row containing several columns. For example, if we have a table of animals, each row could be a different animal, and we could have several columns, one for storing the weight, the height, the color, etc. NoSQL is different. Instead of rows, we will have documents, and each document will have as many fields, which are equivalent to columns in the SQL world, as we want. Each one of these fields can store dates, strings, numbers, lists, objects, arrays, etc. For example, here we are storing several elements that we extracted from a website. This gives us tremendous flexibility. Every document can be different from each other. In the SQL world, we can't do that. Every row will share the same columns. As you can imagine, this NoSQL approach makes a lot of sense for storing parsed contents from websites and text in general. This is because websites are pretty irregular. For this, I will be using Python 1.70 running on Windows. You can download my project from GitHub over here. You can install Python for free by visiting python.com. This exercise will attempt to store some information from Wikipedia pages about countries. I will first call URL open that will request the HTML, and will transform the HTML into a soup object by calling Beautiful Soup on it. I will then grab all the paragraphs and concatenate everything. Here we could use a standard .join to concatenate the text, but we might want to exclude certain paragraphs that contain certain things. This loop, like this, gives us flexibility to do that. We then invoke spaCy and call the NLP function on it. Some context on spaCy first. It is an industrial-grade NLP library meant to work with big workloads that allows us to tokenize text, extract entities, train it on text to do text classification, or apply a big set of syntactical rules. We will use the doc.ents attribute to get all the identified entities. There are many returned here, such as dates, places, etc. I will only keep person and organizations. I will use a list plus set approach to make sure that there are no duplicates, and I will store that into two lists. Then I call the detect function to identify the language. This function is part of the LangDetect module. It is very used in the industry because in general we want to work with documents from a specific language. Finally, we call the keyword extractor from Yake. This will return a list of keywords plus the importance for each one. We then call PySummarization. This is a complex library that uses deep learning to make summaries of text. We need to use it as I am doing here. Finally, I just print the results. On the right panel, I am doing something slightly different. I created a function that will consume all rows from the HTML. Those are TRs. This is done by first finding a table that has the geography class. How do I know that I want the geography class? I navigated through the HTML and search for the element that would help me pinpoint that table that I am after. It will then loop through the rows by finding the row header and the content. Those are the th and td respectively. If the result is non-empty, and I can also find the occurrence of the keyword I am after, I return the value. I want three things: the capital city, the currency, and the electricity type. Finally, I decide to put those three elements into a dictionary. I will explain why in a minute. Finally, we do the fun part. We will insert everything into Mongo. There are several NoSQL databases out there, but Mongo's flexibility, ease of use, and the fact it's free makes it one of the best options out there. For this, we will use PyMongo and call a Mongo client to our database. Since we are running MongoDB on our very same computer, there is no need to do anything else. Of course, before running this example, you need to make sure that you have installed Mongo on your computer. In order to insert stuff into Mongo, we need to pass a dictionary. In our case, we just put together everything that we had before. Maybe the only thing that requires a special comment is the summary part. Remember that a few minutes ago we grabbed the electricity, capital city, and currency and put them together into a dictionary. When this gets inserted into Mongo, it will be inserted as an object, with its respective attributes. In order to run everything, I go to the first panel and click on Run Below. All the panels connected to the out part will be executed, which in my case is everything in here. Let's see how this looks like in Mongo. Pay attention to the summary object I described before. Let's assume we want to rerun everything, but now we want this for Argentina. Instead of having to change our code, we can add a new panel and we just put our code in there. We can hide the Brazil panel just to make it explicitly clear that we're not working with it. We run this again, and this inserts the new document into Mongo. Naturally, we can do queries in Mongo, which would be the equivalent of doing a select everything plus a where statement in SQL. Let's suppose we grab the article that's related to Brazil. This is as simple as calling the .find on the collection. On the other hand, we can select documents and then sort them by calling sort. Let's suppose that we want to select all articles sorted by how old they are.